All right, so today we're going to finish learning about how do we name all of our ions. We'll learn how we name transition metals, and then we'll start to become familiar with something called a polyatomic ion. Okay. So since we're going to talk a lot about ions today, first let's just review that. What is an ion? Negative charge or positive charge. Okay, so any atom with a charge. And then on Wednesday we talked about how metals, they're going to form cations. Okay, so they will lose electrons and have plus charges. Nonmetals are going to form anions, so they will gain electrons and form negative charges. Okay. So let's review why. Why do atoms gain or lose electrons? And it's because they want to have a filled valence shell. Bless you. Do you remember how many electrons atoms want in that valence shell? Good. Okay, so that magic number is 8. So today we're going to talk about something called an oxidation number. That is just the number of electrons lost or gained to get a full valence shell. Okay. So if you want to shorten oxidation number, maybe just copy what I wrote down. Okay, so it turns out some elements have the same oxidation number no matter what. Okay, so we're going to write those down. Before we write the oxidation number down, we're going to write the number of valence electrons. We have to know that to understand the oxidation number. Okay. So on your last blank periodic table, we're going to write 2 rows of numbers above. Okay, so write this set of numbers kind of high because we're going to put another number below it. Okay. So elements in this first column, they have 1 valence electron. Then elements in the second column have 2 valence electrons. And then I'm going to skip the transition metals and I'm going to jump all the way over to here. Okay, so elements in that column have 3 valence electrons. Then the next column is 4. Then it goes 5, 6, 7, 8. So if I were you, in your notes, somehow label that row. That's the number of valence electrons. And so to understand the oxidation number, we need to understand valence electrons. All right, so now for oxidation numbers. This column, they have 1 valence electron. And what's the number they want to have? 8. Okay. Is it easier to gain 7 electrons or lose 1? Lose 1. Okay, so elements in this column, they will lose an electron. If they lose an electron, what kind of charge do they get? Plus 1. Okay. When we write oxidation numbers, we write the number first, then the symbol after. So the oxidation number for the first column is, you can say plus 1, but we write it as 1 plus. All right, the second column, these ones have 2 valence electrons. Is it easier to gain 6 or lose 2? Okay, so these atoms will lose 2. If they lose 2 electrons, what kind of charge will they get? Okay, so these ones will get a plus 2. All right, then we're going to jump over here. These ones have 3 valence electrons. Is it easier to gain 5 or lose 3? Okay, so if they lose 3, what kind of charge do they get? Okay, 3 plus. All right, this column has 4. Is it easier to gain 4 or lose 4? Good, doesn't matter. Okay, this column typically is pretty happy on its own. It's decently stable. However, it could go plus or minus 4. All right, then this column, they already have 5. Is it easier to gain 3 or lose 5? Okay, so now this time if you gain 3 electrons, what kind of charge will they have? Okay, so it's 3 minus. The next column is 6. Is it easier to gain 2 or lose 6? Gain 2. So if you gain 2 extra electrons, what kind of charge will it get? Okay. Then our 7th column has 7. Is it easier to gain 1 or lose 7? Gain 1. So what kind of charge will they get? Okay, negative 1. And then that last column has 8. Are they going to want to gain or lose any electrons? Okay, none, so it's 0. All right, so then make it key. Those numbers we just wrote, Those are the oxidation numbers. Okay. You absolutely need to know these. I would say by like next Friday, you need to have your oxidation numbers memorized. Okay. So if you want, you can like highlight, star them, underline them. But these numbers, you have to know, you have to memorize them. Okay. So that just means everything in the first column will end up with a +1 charge. Okay. Everything in the second column, +2. This column is +3. Then it can go plus or -4, then -3, -2, -1, 0. Okay. So by next Friday, do you think you can have just like those charges over the columns memorized? Yes. Good. All right. Now, do you notice there's a big gap in the periodic table I skipped? Do you see? What do we call this big chunk? Good. All right. So transition metals, most of them can have more than one ionic charge, which is why there's not like this one size fits all rule for them. And then in addition to transition metals, tin and lead also follow this rule. Okay. So even though they're representative, these are big atoms. They can have lots of electrons in them. So these ones can also have multiple charges. All right. Since transition metals can have multiple charges, we have to state the charge in the name. Okay. So we use something called the stock system. How we name transition metals, we just say the name of the metal, and then whatever the charge is goes in Roman numerals in parentheses. So I'm going to use iron as an example. So iron can either have a +2 charge or a +3 charge. Okay. So that means whenever we talk about iron, we have to specify. Okay, so is it the one with the +2 or the +3? So we're going to write out, you can either do the symbol or the name. So Fe is iron, and then in parentheses, Roman numeral 2. Or you can spell out the full name, so spell out iron, and then still Roman numeral 2 in parentheses. Below, iron with the 3+, it could be Fe with the 3 in Roman numerals parentheses, or you can spell it out as iron with Roman numeral 3 in parentheses. And then the way we say this, we would just call it iron 2 or iron 3. All right, this slide you don't need to write down. When we name transition metals these days, we use the stock system. However, I just want to show you like the classical naming system, but you don't need to write this down. You don't need to know this one. I just like to show you, we still have some old chemicals back here, and some of our chemicals are using the classical naming system, so I just want you to be familiar with it. So the old way to name transition metals, we kept the root of the word, and then we added either us or ic to the ending, depending on the charge. The lower cation ends in us, and then the higher ends in ic. So if we go back to the iron example, the 2+ charge is ferrous, and then the 3+ charge is ferric. Okay. So I just bring it up. If you ever see it on the chemical bottles, sometimes just ferrous versus ferric, it's still iron. It's just letting us know which charge it is. Okay. Same thing with copper. Back there, I have like cuprous and cupric. All right, so we're going to practice. Okay, we're just going to practice naming using the stock system. So our first one is Mn. What's the name of the element, Mn? Okay, this one is manganese. And then how do we state that it has that +2 charge? Okay, Roman numeral 2 in parentheses. What's Pb? Pb is lead. How do we write 4? Good. IV. Good. Okay, can you try the next two on your own? What is Sn? Okay, tin. And again, what's 4 in Roman numerals? Good. Okay, and then the last one is still Sn, so what is it? Tin 2. Good. All right, the last thing we're going to talk about today is something called a polyatomic ion. Okay. What does poly mean? Okay. Many. What word is in atomic? Okay, so polyatomic ions. They're just a group of mini atoms. They're bound together, so they act as like one single unit. And if it's an ion, it means it's going to carry an overall charge. So polyatomic ions are extremely common. Like, how many of you have heard like nitrates, like in your food? Are you paying attention to like nitrates? Or have you heard of like sulfates before? Okay. So polyatomic ions, they're very common. So when we name them, they come up a lot. Okay, they're in a lot of our substances. So here's the good news. You do not have to memorize the names and formulas for polyatomic ions. Okay. If you look at the back of your periodic table, do you see how I give you all sorts of names and formulas? Okay, this is what I call the polyatomic ion chart. Okay. You do not need to memorize this chart, you just need to know how to use it. Okay. Okay, so take a look at your chart. It is broken up into two columns. So the left side are the cations, so all the positive charges. The right side are the anions, all the negative charges. And then it does go alphabetically, so that should help you be able to find different polyatomic ions on here. The one thing I want to point out, some of the names and formulas are very, very similar. So for example, let's find sulfate. So find sulfate on this chart. What's the formula for sulfate? SO4 with that 2 minus charge. Look just 3 lower. Do you see how there's also something called sulfite? And it's just SO3 with the minus 2 charge? Okay. So polyatomic ions, they can have very similar names. Ite or ate is just addressing which one has more or less oxygens. So when you use this chart, you just need to be very careful. Okay, so make sure you're actually getting the correct name, like you're not confusing sulfate for sulfite, okay, or like nitrate for nitrite.